So today what we are going to study is called as Hadoop ecosystem concept of one of the component called as yarn. Okay, in our previous class, what we have seen, the Hadoop has three major component, right? What was the three component? One was HDFS, right, which was used to store files, right? Hadoop distributed file system. Second was what? MapReduce, which was used to do the processing, right? And the third component I told you is called as yarn. So today we are going to study what is yarn and why it is used and how it is used. Okay, in terms of setting up the yarn, you don't have to do any setting, it automatically sets it up as part of your installation. But how the yarn process, the map reduce and how the file management happens is being managed by yarn process. Okay, it's one of the component within the Hadoop ecosystem. So yarn stands for yet another resource negotiator. It was introduced in Hadoop 2.0. So basically when the Hadoop first version was launched, that is Hadoop 1.0 was launched, it has got two major components. That is, one is HDFS and other was MapReduce. Only two components were there. The resource management, when I talk about resource management, means how would the tasks be assigned to each of the data nodes, how the processing will happen, was taken care by the Hadoop system itself. Okay, there was no separate entity or the component that was configured as part of the installation. So Hadoop himself used to manage it. But as the cluster size grew, more and more resource management tasks was an overhead within the Hadoop installation. So what did they do? They took out the resource management within the Hadoop and created a separate entity called as yarn. Okay, the whole task of yarn was to manage the resources within the Hadoop ecosystem. Okay, when I say manage means which data node needs to be assigned to, how much utilization you are running with, which data nodes are available, which data nodes are busy, which were stopped, right? All those information management is done by yarn system. Okay, so it was introduced in Hadoop 2.0 to remove the bottleneck of job tracker, which was present in Hadoop 1.0. So in 1.0, you had a resource management system, but it was an overhead because your current processes along with the resource management was eating away the benefits of Hadoop. So it was resolved by creating a separate component and was redesigned resource manager at the time of its launching, but it is now evolved to be known as large scale distributed operating system used in big data processing. So now it is used as a separate component within the Hadoop installation. So this point we are clear? Very simple topic, don't worry about it, it's not so complex. yarn is yet another resource negotiator, is a resource management layer of Hadoop. The basic principle behind yarn is to separate resource management and job scheduling or monitoring function into separate daemon. Basically, what we did in Hadoop 1.0, the job scheduling and the management of resource was held up by the Hadoop ecosystem. But now we have removed it out and created other system where the process will run. So daemon is a word which is used to call it as a process. Okay, in Windows we call it as a process, right? But whenever you talk in Linux term or Unix term, we call it as a daemon. Okay, so it was created as a separate function or separate process to be executed. So now the Apache yarn framework consists of three things. So this is important. So yarn, when it is configured for resource management, it has got three important entities. Okay, the first entity is called as master daemon. Okay, the second entity is called as slave daemon, and third one is called as application master. Okay, there are three things that yarn holds within it. Okay, all these three things are a process. Process, everyone understands? Process, it's like a job. Okay, it's like a job. So when you go to the Windows and click on task manager, right, and you see the tasks which are running and you can kill any job, right? Whatever you see is a process, right, which has got process ID. Similar to that, when yarn is set up as part of Hadoop installation, it has got three processes running. One is called as master daemon, second is called slave, and third is called as application master. Okay, inside the yarn framework we have two daemons, resource manager and node manager. So within the framework we had two more processes. One is called as node manager and other is called as resource manager. I will explain you what all these means, okay? Just remember the name. Okay, they each have a specific functionality why it is written. The resource manager arbitrates resourcing among all the competing application in the system. So RM, resource manager is, think about arbitration means, anyone know the meaning of arbitration? Have you ever heard the word arbitrator or arbitration? Where?
Courts, no one is.
Courts. Who does the arbitration?
Lawyer. The
Judge. Judge does the arbitration. So someone who makes an agreement of the different parties to make a decision, right? Who convince other person. So basically, resource manager is an arbitrator. Think about resource manager is the most powerful entity in the entire YAN system. Okay. What it does is it manages resources among competing applications in the system. So what it does is if there are multiple applications coming in for a resource to be executed, let's say there is a map reduce program for word count, there is a map reduce program for finding the highest or maximum number in a data set, two application, or think about two application as one as a Word document, other as a Excel document, two applications, right? If they both come to the resource manager, the task of resource manager is to have an agreement from all the competing application in the system. It will see in which all competing application where it can be resided and be executed. Okay, so basically it tells the program where to go and where to run. Okay. The resources like CPU, memory, disk, network, and so on is also measured by the resource manager. Because in order to give a task to any particular data node, in order to give a task to any of the slave nodes, the resource manager need to know whether that resource is available or not. How will that resource manager be available to know, like come to know whether the resources are available? It will continuously track their utilization. It will continuously track their processes running over it. Then only it can assign and get an agreement, go and run there. Okay. The application master negotiate resources with resource manager and it works with node manager to execute and monitor the job. So what is the task of application master? So everyone is clear with the resource manager? Think about resource manager is a warehouse having all the slave node information with all the slave nodes processing capability, what they are doing, where they are, what they are executing, it has got all the information. Application master is a job or a daemon process which holds application to be executed. Okay. So as I told you, there are two application. Let's say there is a Excel application and a Notepad application or the Word application. Then it comes to application master. Application master goes to the resource manager and gets a negotiation saying that, okay, tell me which data node I should go and execute these programs. Okay, so application master is more of a person who negotiates with the resource manager, asking for the resource to run the program. What is the resource manager task? Resource manager task is to ensure that whatever information are available for me to do the execution is with me. So think about resource manager is a guy who has what you say, who is a repository of all the resources with him. Okay, and application master is someone who comes to his store and say that, okay, I have 4 jobs to run. Can you tell me where I can run? So the resource manager will say, oh, out of these 100 nodes, go to node 5, node 10, node 15, and node 20 and go and run there. Okay. So application master first will negotiate with the resource manager will assign the resources. When it assigns the resources, where will it run? It will run in the slave node or the data node, right? When it goes and run in the data node, that data node we will call it as a data node where the process will run, right? The actual program will run, right? Slave node. There is one more process called as node manager. Okay, there a process is there which is called as node managers. So when application master gets the resource identification from the resource manager, goes to the data node. Within the data node, there is a process called as node manager running. Okay, it runs in the data node. While running the job on the data node, the node manager constantly monitors how the process is running. Clear? Or do you want me to explain again? Okay, let me explain it with a simplistic example. Think about you all are data node, okay? All of you are data node as a slave. I am a application master, right? Who wants to give you the task to run something. Okay. I don't know you all. Okay, I don't know you all whether you all are available or you are not available, right? So I have no clue of that, but I have only information within the application master that I have to run this 5 job. Okay. The first thing I will go is I will go to the resource manager. Resource manager may be your college staff. Okay, I will ask that, okay, I need to run, I have to do this fast 5 tasks. Can you assign me the resources? So this guy will tell, okay, in this class, there's 5 students are available, go and get your job executed there. Okay. I took that information, I go to all those 5 students. Okay. I said, you have to do this task. I assign one task to each of you. When you are processing or when you are executing that task, right? When you're using the task to process it, I need to know, when I say I need, resource manager, the guy who has given your name, needs to know that you are busy. Why? Because if some other process comes and asks for the resource, you are not available, right? So resource manager should be updated, right? Who will update resource manager? I'm not going to update it because I have given the task. Resource manager will not automatically get the information whether they are busy or not, right? So there is one process that is running in the data node called as node manager. Means there is one process running within your system itself, which will continuously track the process status on your machine, on your individual, and continuously send an heartbeat to resource manager. You understand heartbeat, right? Continuously ping it. Like, so you have a ping command in your laptop, right?
Yeah.
Ping 127.0.0.1. That is a local host. You check your own IP address is active or not. If you have to connect to the remote machine, you give ping, then you give the IP address, and then you see the log which says time to live TTL, and it will give some response time, right? 5, 7, 10 times, right? What are you trying to do? You are testing the system whether it is up and running or not. Similar thing happens here. Each of the name node or each of the data node has a process called as node manager running over it, which continuously check what processes is running within their node and give that information to the resource manager to ensure that the utilization is known to the resource manager, right? If the information is not known, how would they assign the next task to you? Once the node manager says yes, all the process completed, resources are released, I am available again. So the resource manager can assign another task to node manager if new request comes from the application master. Clear? Any questions on this? Any questions?
Sir,
Yes,
the master daemon is also the resource manager.
sorry.
They're the same, master daemon and resource manager.
Yeah, master daemon and the resource manager name is same. Slave daemon is also called as a node manager because node manager is residing in the data node. That data node we call it as a slave. So you can call it a slave node or slave daemon. Application master is one per application. So you can have multiple application master running over a Hadoop ecosystem. I can have 100 of not 100, maybe 10 of application master, each having 10 jobs to do. Right? They can run on different name nodes. Oh, sorry, data node. Okay. Any question with this? Okay. So the 3 important elements of YARN architecture are resource manager, application master, and node manager. So I have already explained it. I will read it again in more in depth of what does each of them do in terms of the functionality. The resource manager or RM, which is usually one per cluster. So one per cluster means where should it reside? It should reside in the name node or the master node, because that master node only controls all the slave nodes, right? So one per cluster is the master server. Mostly, majority of the time, resource manager will always and always reside in the name node or the master node. Okay, so if there are two name node as a load balancer, then it will reside in two places through a load balancer. Okay. Resource manager knows the location of the data node. Everyone agrees with this line? Resource manager should know the location of the data node.
Yes.
Yes. How will it know? You remember this file? In week 2, I told this file, what does it information it holds?
Metadata.
It stores metadata of what?
Data node.
All the data nodes like IP address, your partition, your location, your cluster, rack, and all those information, right? So resource manager knows the location of the data node. Means why should it know the location of the data node? Because it wants to know whether the data node is active or passive, whether it is running or it is down, right? If it is running, what it is running, is it available for taking up task or is not available for taking task? Is the disk space is empty or disk space is full? Is the CPU utilization is within the threshold or is it higher than that? Is the memory allocation available or not, right? All those information needs to be known by the resource manager. This information is referred to as rack awareness. Why it is referred as rack awareness? Because when we talk about Hadoop in a cluster, I told you about cluster has got, cluster is nothing but a group of large servers hosted in a data center, right? I explained you the cluster, like you can have a big room where a lot of machines are hosted through a network cable, right? So it is also referred as a rack awareness because it gives the information of which rack, which level, which machine, all that information is available as part of rack awareness. The resource manager runs several services. The most important of which is the resource scheduler that decides how to assign the resources, right? So resource scheduler is something that is residing in resource manager. As I gave you an example, if I go to that person in your college and ask that I need resources, right? If he assigns 5 resources, that person should also know when you will get free, right? So he should schedule that activity. Okay, this task will take 2 hours. After 2 hours, these 5 will be freed. So that scheduling activity is also managed by the resource manager. What is application master? Application master is a framework specific process that negotiate resources from a single app for the single application. As I told you, if application master will negotiate with the resource manager for a single application. There may be many applications by the application master also. Okay. That is single job or directed acyclic graph of job. We will study about DAG. Anyone know about directed acyclic graph? We will study about it, but have you heard about this word? Anyone from computer science engineering background? Data structure, anyone has studied? Okay. So directed acyclic graph is a graph without a cycle, in a very simplistic term. Okay, for example, directed acyclic graph may be cyclic graph, everyone understand, right? Something which starts and reaches to this initial point, right? That's a circle, right? Cyclic. Any flow process which starts and never goes to back to the original position in a workflow is called as acyclic. For example, I launch a URL, I log in with a user ID password, I click on check my mail, I open a mail, just click on reply button, reply to the mail, click on send button, go back to the home page and log out. Did I again give the user credential? I never gave, right? So I never return back to the same place to start over again, right? So any flow process which doesn't have a cyclic behavior, we will study in Spark, which is called as RDD. But for a time being, you can have application master can have a single job or a directed acyclic graph job. Okay. Which runs on the first container allocated for the purpose. So whenever job is assigned to the application master and it negotiate with the resource manager for the resource, what it does, it finds the first, whichever resource it has been assigned, it gets the first container and allocate the job for that purpose to execute. Why it is first container? Any idea? Why not second, third, fifth, 10th? People need to ask me the question, otherwise how will, even if I am asking it, because I think this should be a good question, but you need to ask me. Graph which runs in the first container allocated for the purpose. Why first container? First container? Okay, so if I give you a task, right? So as a first person, if I give you a task and if I give you a task to the first person, if the first person is not able to do it, what it will happen? It will spill over to the second one. But if I split the work already into second, fifth, 10th, I will never know which one is fully properly optimized and used, right? I need to maximize the utilization and optimize the process. So when I give a task to you, if I find that you are able to do it, I will not assign other resources to it, right? If I give a task to you and if you spill over the work, then only I will say, okay, it's not being handled properly by one person, now you take the second one, right? This is a strategy which saves, or I would not call save it, improves the efficiency of the execution. Okay, because if I split the job into multiple container, then I'm misusing the resource, right? I give it to the one, if that job takes more resources that is required or that is available by the first container, then only switch on second one and then get it shared. If it is already shared, then I am not utilizing the resource properly, right? So think about, you go to a car shop, right, and you want to change your tires, okay? A guy comes and start removing the tires, but you are in rush. So you give the task and this guy mechanic starts doing it and you find no, it will take more time. What will you do? What will you tell that guy? Can you bring another one? Why didn't you ask for bringing 4 guys at once? To save time. Why didn't you ask?
Sure.
But think about, why didn't you ask?
One expensive.
One is expensive. When I say expensive means what?
Costs more.
It costs more, means I'm wasting more resources to do a certain task which can be better handled by one person, right? Unless I really need to do it fast. Then I will split the job into multiple containers. But I will start with the first one only, right? So that's the concept. Each application master requests resource from the resource manager and then works with the container provided by the node manager. So once the resource has been assigned, the job is subjected to that node data node where the node manager is running. What is the task of node manager? Node manager can be mainly many in one cluster. Everyone agrees with it. They are slaves of the infrastructure. When it starts, it announces itself to the resource manager and periodically sends a heartbeat to the resource manager. So whenever you start a new node in the data node in a cluster, let's say I have 10, I wanted to spin up another 4 data node. Whenever it starts, what is the first thing it does? It announces that yeah, I am present. Why is it announcing it? Because when it announces, resource manager adds that into the list of files, saying that yes, earlier I have 10, now I have 4 more, right? So this node manager, whenever starts up in the data node, it announces itself to the resource manager, now it's available and we can take more tasks, right? Even after finishing a job and the node manager again sends a message to the resource manager that I have completed the task, now I'm again available to take up the new task, okay? Each node manager offers resources to the cluster. The resource capacity is the amount of memory and the number of V core short of the virtual core. So what it does is, whenever a node manager announces itself, what does it announce? It announces that yes, I am alive, I am available for it, I have got 4 core of memory, I have 4 core of CPU, 16 gigs of memory and 180 GB of disk space with me. Why that information is announced to the resource manager?
So that you can know what resources are available and what.
So that when the new job comes, the resource manager can arbitrate with the application master depending upon the application size. How much resource and where it can assign. If I don't know what is your capability, what type of assignment I can give you? It's simply like that. Unless I know what is the capability of that person, based on that only I will give you the task to do it, right? If I start giving you a task which is not beyond your capability, then there is no point, right? So the node manager, when it announces itself through an heartbeat to the resource manager, it also tells the capability it has to support the job execution based on the memory and the weak core available with it. At the runtime, resource scheduler decide how to use the capacity. The container is a fraction of the node manager capacity and is used by the client to run the program. So we will see in the diagram. So if you see here, this is resource manager, right? Where it is residing? It is residing in the name node or a master node. Clear? It has got something called as scheduler and other is called as an application manager. I will explain about application manager also and little bit more about scheduler. For a time being, resource manager task is what? It has information of all the data node, right? It has all the information in the data node with the resource manager. It has also having a real-time update about the data node through node manager, because node manager is continuously pinging it saying that, oh, I am busy, I am available, my CPU is up, my memory is sufficient, right? All this node manager will be sending the information to, yes.
So you said data node, the node manager constantly sends heartbeats to the resource manager.
Yes.
Now, when he's through with his current job, if he's less busy, does he still send the heartbeats? How does he know?
It will just continuously send an heartbeat in terms of the ping command, like the way you do it.
Yeah, I know.
Right.
Perhaps how does the resource manager tell the difference as to when he's saying I'm less busy or I'm not less busy?
Good question. So when the node manager sends this information to resource manager, it is in a form of a log. Okay, it has got a information. Again, when I say log, you don't read log. You get it in a monitoring dashboard report. So you can go there and you can directly see. Right. So what resource manager does it only collects the information. Right. So your architect will configure this. That okay, till 80% is good for me, 70% is good for me, 85% is bad for me. If the particular node manager or data node is running with 80% utilization, don't give any other task. That we will configure, right? That's something which you have to configure based on your application. But the task is resource manager, when you set up those threshold levels, based on those levels, resource manager will decide where to give what job. Okay. So these are your slave nodes. Slave node has got node manager. What is the task of node manager? Node manager is first when it is coming up, it will notify the resource manager it is up and running. Correct? First task. Second task is it will periodically send the utilization of CPU, memory, all those information. We go to the resource manager so that resource manager is always up to date with the current status of all the data nodes. Correct? Now each of the node manager has got something called as application master. What is application master? I told you application master is nothing but an application like Word document, Excel. Think about application as any program, map reduce program or any program, right? Now application master once negotiated with the resource manager, the first step, once it negotiates it, let's say it is assigning the first node manager here, right? So you came from here, application master goes to the resource manager saying that, oh, I need to process this job. Where should I go? So resource manager say, oh, go to this node manager 1. This node manager 1 has enough capacity to run it. Run your program there. Okay. So the application master's application gets resided in the data node or the slave machine. Now it gets resided. It is not going to sit there. It will do something, right? Isn't it?
Yeah.
You have given, like I gave you an assignment after being assigned by your college staff that go and talk to these 5 people, they will do your job. I take the job, I come to you, I gave you the job. what are you going to do with the job? You're going to process it, we are going to execute it. Where will you execute it? You need a place where you will execute it, right? That place where you execute is called as container. So, have you heard about the word containers?
Yeah.
What are containers? I think I explained you, right?
So I think container, in terms of the way we use it in maybe in servers and all of that, it takes a little less resources rather than setting up it.
Very good. In terms of Java also, in terms of any place in IT technology, containers are a small unit of processing. Okay, I think I explained you all. So if you are building an application, I told you, if you take a big application like Amazon.com, right, website, Amazon.ca. So how many lines of code would be there for that application? Maybe a million line code, right? So people would have written all the codes in different sections, right? And it used to happen 15 years back, not 15, I would call it as 10, 12 years back. Whenever the change was pushed in the application, so you used to bring all the application down, right? You used to bring it down from the production, right? And then you will package it and then deploy it on the server, right? And then host and restart the IaaS server so that everyone can access the site. The problem with that type of project was your code is becoming bulky day by day, right? Becoming huge, right? Now, every time when you package it, you have to first compile it, right? Isn't it? You will compile it. So you will compile it and then you will test it and then you will run it and everything is fine. Then you will again zip it. Let's say zip, what do you call it as? Package it, right? In Visual Studio, call it packaging. You will first, what do? You zip it and then you send it, right? And when you deploy it through Jenkins or DevOps pipelines through Helios, you'll deploy it in production. The entire process of single package, let's say one software package of 20 gigs, right? 20 gigs. You after zipping it. When you go to the production server, you have to unzip it also. Right? You have to unzip it, right?
Yeah.
You unzip it. Now you unzip it, what you will do next? Then you will do all the configuration, right? Configuration in terms of setting up the port number and all those things, you will do it. And then your service is up and running. So if I do this process, it will take like a midnight, a whole night. That's why 10, 15 years back, you would have heard that any IT company or the project which you are working, they will say, oh, we have a deployment. So normally deployment, they will do it on Friday night. Right? They will do it on Friday night so that anything goes wrong till morning, they can still have Saturday night to fix it and put it live on Monday, right? 2 days. So basically 24 hours is a huge window, right? You cannot spend that much of time to do a deployment today. So what they used to do, like, so normally they used to have like this. So let's say this is internet, right? www. Okay. So you have your gateway like your app. Then you enter to the company site, right? Within the gateway, they will have the load balancer. Everyone understand load balancer, right? Within load balancer, they will have one as active and one will have as a passive, right? And within the active passive, they will have web service layer, API layer, and then you have a database, right? Then you have web services, and then you will have. I'm just drawing one database, okay? This is your database, right? This type of architecture is called as 3-tier, right? Why? One tier, that is application tier, other tier is service layer, and this is the database, right? Only thing will change in 3-tier is this becomes more and more expanded, right? Sub-task, right? But overall architecture n-tier or 10-tier, basically everything is 3-tier, right? Now, what used to happen earlier deployment? So let's say this is live application, this is Amazon.com site, right? You don't see Amazon.com site coming down anytime, right?
Yeah.
Let's say 10 years back also it was never down, right? So what they will use to do is, let's say they have a new package, new feature added in the code. They will first zip it or package it together, all the code written, right? They will zip it and make one big package. Let's say the size of this package is 100 gigs, right? What will they do? During a fraction of second, so right now both this code is, let's say this is release one code, this is release one code. So both has the same copy running in production today. This is only in a standby mode. Standby mode means if something goes wrong, then it will switch over. Otherwise, it is everything is running fine, let it run fine. This is on a standby mode. If I have to do the deployment, I will do this, take this and put it here. Release 2 code. Okay, I will do the deployment here. I'm not touching the live. I'm having the everyone in the internet to use my site. I'm doing the work in second one. Why it was done on Friday night or Saturday night? Because the traffic is always low. I'm talking about the site which are not an e-commerce site. Think about Amazon is not an e-commerce site. Okay, depending on the usage pattern, they will say this is a time when the less number of users are there. So they will deploy the code. This is running as it is, right? Once the deployment is done, unzip is done, code is deployed, configuration is done, port is done, everything is done. Now what we will do? We will switch it. I will make this as active and make this as passive, right? I will swap it. This swapping will take how much time? Maybe a minute or so. But if you see in last 10-15 years, they will have a small downtime, right? They will say in the midnight, if you go to CRA site, right? It is not available every day from morning 1 o'clock till morning 5 o'clock. Try to log in, it will say it's under maintenance. They give a long window, but it normally takes 5 to 10 minutes maximum to switch it. So once it is switched, the new code is here. Every user is directed here, right? So let's say they did it on Friday night, everything went fine. On Saturday, they will do it here. Clear?
Yeah.
Let's say Friday night, everything was going fine, but on Monday it broke. What they will do? They'll switch it back to the old code. So let's say this was fine on Friday night, Saturday night was fine, Sunday night was fine. On Monday, when the huge bulk of users start coming and this started getting some error, which was not visible on Friday night, Saturday night, Sunday night. What they will do? They'll roll back. That's why you had heard the term rollback of the code. What they are doing, they are not rolling back the code, they are actually rolling back the instance where they are pointed to, swapping it. Swap it back to the old code and let the new code be again fixed. And once it is fixed, roll it back. Right? The problem with this mechanism was the deployment process used to take long time. Because if I'm deploying a code of 100 gigs, it takes long time, right? I have to unzip it, check all the configuration. I have to have 50 different people who have written the code in 50 different places to see, right? There's not one developer, right? Big program maybe are 50 developer, 50 support, hundreds of support guys. They have to see, and each one is not knowing what other one is doing. So let's say you have written a code for user ID password login by validating your right user or not. I am writing a code where the search is there for a product in Amazon, right? You have written a code for only for authenticating, but you missed to add a feature that, okay, if the user is sitting in Canada, don't show him this product, which is in you, let's say, which is in Japan, right? It can be, and you missed to write the code. I don't know what you have written, you don't know what I have written. If I ask you to fix my code, you cannot fix it, and if you ask me to fix your code, I cannot fix it because I have not written it. The challenge with this model was the waterfall model, where you deploy the code and you face a problem, you end up days to fix it, right? Then we moved to a concept called as agile, right? Where we divided the project into smaller modules, right? What is the concept of smaller module? Now this 100 gigs of package, right? What I will do, I will break this into small module. One page, one module will be login, launch. You understand launch URL, right? Website launch. Second is login. Third is search module. Fourth is add to cart. Fifth is proceed to checkout by payment of credit card, and sixth is logout. Right? What did I do? I created a small module. Right? Now, if I have to deploy a code which has changed, let's say this particular release, only search module has changed, where I've added new product. Do I need to compile all of them?
No.
No, because this one work fine, this one work fine, this one work fine, this one fine, right? I want to deploy them on Monday only. I can't wait till Friday because there's a business need. I have money to collect because of the sales. I cannot wait wait another 4 days on Friday so that everything gets compiled, go and deploy there, right? Having a loss of business. What should I do?
Deploy.
I should have a mechanism where I can only deploy this piece of the code without affecting others. Right? How should I do it? Because here I have to deploy it on one complete server, right? Full server is occupied by deployment, right? Unzipping it, compiling it. If I take this server and broke it down into containers, broke it down into container means smaller processing units, right? This is container 1, this is container 2, this is container 3, this is container 4, this is container 5, this is container 6. Container means smaller processing unit, which will have a memory, which will have a CPU and RAM and all those stuff, right? And I will deploy just these things in their individual containers, right? Correct?
Yeah.
So when I talk about container, these are OpenShift container, if you heard about the word, or microservices, you have heard about it.
Yeah.
So we created small module and then we connected each other through a web service layer API. Anyways, they are going to talk, right? So someone who has logged in should be able to log in, should be able to search, should be able to, right? They're connected. Now, if I have to deploy a code of search, do I need to bring all this other one down?
No.
No, I can only bring this one down and deploy the code and restart the pod or restart the container. Everything is smoothly, right? Right? Since this code is a small package of the entire code, how long it will take to deploy? Maybe a minute. How long it will take to test it? Maybe a half an hour. Right? Will it not be fast? Right? So when you break it down into smaller container, so if processing becomes faster, deployment becomes faster, change becomes faster. You move to the faster business delivery. Right? So when you move the container, same thing I explained it here. When you have a resource manager, application master gets this from resource manager, which data node needs to be run, goes to the node manager and executes it. Where does it execute? It executes in the container, the small processing unit which is residing there.
So, one quick one before you continue.
Yes.
When you, with these assignments you gave us, when we want to start the whole Hadoop, we go into the terminal, we do start HDFS, .cmd, and you do the start DFS command.
You will not do that because that is held up by, you don't start and stop Hadoop enterprise. In a large organization, you will not be having a authority or access to start the Hadoop system.
Okay, so how does it work there then?
So what you basically normally what happens is Hadoop is an ecosystem you will learn, right? You will know how to put the files. So what you will be getting a task, I'm just giving some sample examples. So if you go as a part of a data analyst, right, role, they might tell you that, okay, there is a system A and there is a system B. System B is a big data or Hadoop system, right? Data is coming from A, right? Data is coming from A. Can you take this data, clean it, process it and load it into the Hadoop ecosystem? The command is put, right? You can put it, but it's not simple put. They will ask you to clean the data. Clean the data, you have to partition the data, you have to split the files, you have to understand how once you split it file, which all cluster it is going to spread, right? Once it is stored, then the guy who is working on the machine learning as a data scientist, he will put a machine learning program on your data which is stored and do the analytical part of it. There are two different roles. You will also be responsible to see if you load multiple data files at the same time, what happens? Till now you are doing only one put file. If I ask you to put hundreds of the files in parallel, what will happen?
In what?
Hadoop HDFS file system.
Yeah, you have to clean the files individually.
So let's say I will give you, we have around 300 gigs of data loaded every day, right? 300 gigs is a huge file. Out of that, we have close to 800 files coming from Broadridge to be loaded in RBC wealth management database, which is similar to Hadoop, but we don't use Hadoop product, we use something else that is single store. I have to load it. If I ask you how will you load it? So what you cannot write a program of put 800, because when you load the file, there are relationship between the file. Because when you store it in the Hadoop distributed file system, it should maintain some relationship. That you customer account cannot come after the data of sales. Obviously, what will sales data will do without a customer information? So there are parallel execution, sequential execution, all those planning you have to do. How the files will arrive, where will it arrive, where it will be dumped, how will I pick it up from that location, get command, how will I use put command, how will I split it, how if that split is done, how will I filter this data, how will I clean it, how will I validate it. You remember the first class I told you there are 4 V's, velocity, veracity and 4 V's were there, right?
Yeah.
What one was the veracity. Would you not like to check the data which is arriving is not garbage or something corrupted? Right? You have to check it, right? Otherwise, you are going to bombard the database with the dirty data which is not required. Or even if you are not checking properly, there may be primary key field which is empty in the log. So when you load it, will throw an error, right? So all those things you have to do it, right?
So it means that on the field, we just need to get the concept of how
Yes.
Hadoop works. If we find another tool that they are using, which probably would be entirely different from Hadoop, we just have to apply the principle.
The principle remains the same. The concept still remains same. Only thing that will change is the syntax for you.
Okay,
Okay, like your word count problem, right? That's only for word searching number of times the word occur. But if I give you a data where I ask you there is a sales of a Walmart across GTA for every month for last 10 years. Can you give me which particular center gave the largest sale of a specific product on a particular month? Then you have to use map reduce program only. But the thing will change is your mapper program will still remain the same, reading the line by line, finding the key value there. But the reducer program will change where you will say, rather than finding the word count, you have to start writing field column name, sales, month, all those fields here. Just change the logic there. Program functionality still remains the same. Okay. Clear?
yeah.
Okay. Yan and his architecture, resource manager is the ultimate authority that arbitrates resources among all the applications in the system. The node manager is the per machine framework agent who is responsible for containers, monitoring the resources, CPU, memory, disk, network, and reporting the same to the resource manager or scheduler. Clear?
Yeah.
Now, what is the task of resource manager? I told you resource manager, 2 processes running, right? One is called as scheduler, other is called as application manager. What is the task of scheduler? Very important. Look here. Responsible for allocating the resources to the various running application subject to familiar constraint of capacities, queues. I already told. Resource manager should know what? Which one person is up and running? What is the capacity of that person? Right? What is there any queue job running or no? If it is already occupied, whether it is blocked, all those information scheduler will have. What it will do if the resource manager finds a data node or a slave node or a node manager is available, it will assign the task, right? Scheduler is only to assign a task. That's it. It schedules the task. Okay, it's is a pure scheduler in the sense that it performs no monitoring. Resource manager subcomponent scheduler only assigns the task and schedules it, but it will not monitor how the node manager is working. How it is working will be responsible for application manager. Both are together inside the resource manager only. This resource manager which you see, right? Within that, there are 2 things. One is scheduler and other is application manager, right? When I was explaining that application master comes to the resource manager and the resource manager will tell, okay, go to this data node and run the job. That is the task of scheduler. Once the job is assigned to that particular data node and the name node is running, node manager is running and providing the heartbeat to resource manager saying that yes, I'm running, I'm busy, I'm utilizing 80-90% of resources. That information is being maintained by application manager within the resource manager. Clear?
Yeah.
Application manager responsible for accepting sub-job submission, negotiating the first container for executing the application specific application master, and provide the services for restarting the application master container of failure. So if any node manager reports that I have failed, have failed executing or something has gone wrong and the node manager is reporting that it needs to be restarted, all those information needs to be updated to resource manager, and resource manager will send a command to restart it. Or stop the process. There may be many times that the process is taking too long to run, right? It's not completing, right? It gets hanged, right? So in order to kill the process also, resource manager will have certain timeout set. Within that time period, if it is not done, it will kill the process and restart the job. Okay? Clear?
Yeah.
Scalability in Hadoop, vertical and horizontal scaling. Do I need to explain this?
No,
Yes or no?
no for me.
Yes or no, quickly? No.
Yes.
Okay. Data locality in Hadoop. How many of you remember data locality?
Right.
What is data locality?
So in the locality, it has around in data node instead of in.
Yes, so the processing happens on the data node where the data resides, right? You are sending the mapper and reducer program to the data node to execute it, not the reverse way. You're not running everything in the name node in the Hadoop architecture. So data locality is also 3 types. Okay, first type is called as data local. Data local is nothing but your laptop. You having name node and data node residing on the same laptop. That type of setting is called as data local. Means everything is local to your own machine, right? Your data node is also there, name node is also there. Everything is executing in the closest proximity of the name node. Clear? What is intra-rack data locality in Hadoop? Intra-rack locality in Hadoop means when the data is split and stored in the same rack of the cluster. Cluster, let's say a cluster is like a library. Think about library and you have racks, right? Aisle A, aisle B. Think about cluster like a Walmart having different aisle. Each aisle is one rack. If the data is stored in one rack within the same cluster, then it is called an intra-rack. Means if the data is split and there is a single aisle, one portion of the data is kept at the top rack, second one in the middle and third one in the bottom. It's split, right? But it is in the same rack. Processing will be poor than this, but faster than this one. Because they are connected through network wire, right? At the backside. So the search would have to happen within that same rack, right?
Yeah.
The third, which is I would say in terms of response time is slowest, is called as inter-rack. Means if one data is stored in aisle A and other data is stored in aisle Z. Right? So one data can be picked up here, but to go from A to Z, then it has to go through network wire and go there and search in that rack, right? So that is the, I would call it as the mechanism to store the data. Everything has a benefit and disadvantage. In first case, the reliability is very poor. Although data is residing in the same place, if your one place goes, everything burns out, right? In case of intra-rack, again, your performance is good, not as good as it is from here because there will be some network delay, but it is better than in terms of reliability because you are storing a data in the same rack, top, middle, and bottom, right? 3 racks, right?
Yeah.
But the problem with this is also that your response time or the slowness increases little bit, right? Little bit means when I said 10-15 millisecond, you will not understand it, but again, it's still huge in terms of data we are talking about. Another disadvantage will be if that rack itself is down, right? You can have the entire rack shelf down, right? Then you can have a data loss, right? The best is in terms of reliability is inter-rack when the data is split into multiple racks in different aisles or multiple racks on different clusters also across the geographical area. Like one is in US, other one is let's say in Japan, other one is Australia, right? But the problem with this is although it is reliable, but it adds a lot of network delay because it has to pull up from different places. But it is most reliable one. Okay? Clear?
Yeah.
So how to run MapReduce, which we have already done. One was through MapReduce by invoking relevant module, the second assignment, where you directly run the jar, right? And the second option was using a Python utility where you executed the jar using the Python script of mapper and reducer. Clear? Okay, second option is more effective due to the implementation of resource management in Yarn. You cannot see, if you remember in the last class, I told you to use a program which is an optimized version of
Yeah.
mapper. Did I tell you?
Yeah.
If you take a big file, right, to do a word count, let's say you take a 40 MB file and then you do the first assignment to run directly with the jar, and when you run it, you will see a log coming in the command prompt in the bottom. So you'll see the split, you will see the block, you will see the size, you will see the time it spent to run the mapper, time it spent to run the reducer. You will get the time in milliseconds.
Yeah.
Take that copy and use the second option script and run the same thing and copy the same thing and put parallel to each other. What you will see that in case of the second option, when you run the Python script, Yarn uses the resource management more effectively because you are splitting the mapper and reducer program optimized way versus the first one, which is a default jar provided to you. Okay. Advantages of Hadoop. Do I need to read it? Varied data sources, availability, scalable, cost effective, low traffic, ease of use, performance, high throughput, compatibility, fault tolerant and open source, multi-language support. Any questions on this?
High throughput, what does that get more benefit for everyone? The high throughput.
High throughput, because parallel processing. High throughput means amount of data transfer per unit of time.
Yeah.
So if you are having multiple processes running in parallel, you have more data processing happening, right, per unit of time. So you will have high throughput. So valid data source means it supports text, CSV, and other files to be loaded in HDFS file system, right? You can store the blob file, you can store text file, you can store CSV file, any format of file can be stored in Hadoop distributed file system. That's the one advantage. It's a cost effective. Why? Because you have slave data node which are low commodity resources which cost less. So it's a very cost effective way of managing Hadoop clusters, right? You don't have to auto scale, vertical scale or horizontal scale with the physical machines, right? Performance of Hadoop is faster because it runs over a distributed Hadoop distributed file system. Because parallel processing happens, your performance improves, right? Fault tolerant. So Hadoop has a one important concept called as fault tolerant. This I will explain you. And again, you need to know this. So what is fault tolerant? Fault tolerant means the Hadoop ensures that the data is not lost. That's a fault tolerant, right? Even if your failure happens, you still don't lose the data. How would you do that? You need a mechanism where you can, one is replication, right? So there is some concept which is called as erasure coding, EC coding. So how many of you have, don't read this, I will explain you, then you will understand what is written there. And then after this, there is not much of the topic to be remembered, but this is important, you need to know this. Again, this is more of a encoding technique. Encoding means converting the data into certain format which cannot be easily deciphered, right? So there may be many methods of doing it, but I will explain you one or two methods to understand erasure encoding. So first thing you need to understand is, you heard this word before.
Yes.
What does it mean?
The read is
Faster.
okay. Array of independent disk.
What independent disk?
Oh,
Madam? No? Next, madam. Next one to you. Red.
A way of organizing disks, drives,
Organizing disk?
yeah, to replicate.
Yes, for replication.
replication.
So one logic I will tell you, whenever you see any terminology in IT, try to resemble with the real world wording. Okay, you will never forget it. R stands for redundant. A stands for array. I stands for independent. And D stands for? What do you mean by redundant? Redundant. Hmm? Redundant. I am doing a redundant work means repeating.
You have the kind of vacuum, you have.
More than once.
See, people always think about software. I'm talking about very basic sense. I said I am doing the work redundantly. Means what? Repeatedly. Right? Redundant means something that can be repeated. Right? A for array. Array everyone knows. What is array?
Like a list,
Array is not list.
like I said, it's like line of few array of.
Anyone who can specify what is array.
Okay, they're organized.
You people are not studying in terms of understanding, people are just studying for, okay, so if I write. And tell me whether this is an array or not. Is this an array?
This is a list.
Or I'll put it something more. I'll put one more. Is this an array? It's a list, right?
Yeah.
Is it an array? Isn't it a list? But can I call it as an array? Guys, you need to be faster, otherwise it will take 15 minutes for me to explain this one. How many of you say it's an array?
No, it's not an array.
Why?
I think an array would be a combination of a number of lists.
Is array the same data type?
Very good. Array should always and always be of same type. Array cannot be, if this array is of fruits, then everything should be fruits. If array is just for vegetables, everything should be vegetable. If array is for number, everything, can you define an array C or Python or anywhere by mixing and matching? Cannot define it. So anything that is of same type, redundant array means repeated item of the same type. If it is a disk, then it should be of same type, right? When I say same type means everything should be HDD or everything should be what you call it as SD, right? Redundant array I for independent means although they are repeated, but they are independent. They are not getting affected by anyone else in the group, right? Redundant array of independent disk. So if I have to replicate a data, there are many RAID forms. One is called as RAID 0. RAID 0 means no replication. One place your copy is there, that's it. Very inefficient, very high in fault, right? If that machine goes, everything goes, right? Then you have RAID as RAID. I think RAID 0, RAID 1. RAID 1 will have two disks. Having the same copy, two places. If one goes down, we can pick up the data from other place, right? Then you have RAID 5. I will have 5. Right? Then RAID 10. RAID 10 is a very high, very high reliability source, but normally even the best of the best, they keep 5 copies. Okay? So RAID 5 has got 5 replication. What is the problem with the RAID? It solves one problem of fault that if your data gets, let's say this particular disk got corrupted, you still have the data on 4 places, right? You can reformat it and copy the data here, right? If 3 out of 5 gets corrupted, then also you still have a problem. Fix it. The problem with the RAID is it although have a reliability of availability of the data, but it doesn't solve the problem of data loss with piracy. You understand piracy, right? Data lost by hacking. So if somebody gets an access to one of the disks, what will happen?
It knows what's on all the other disks.
It knows everything, right? What's the point of having a reliability with a low, I would call it, what do you say? Low security, right? What should I do? I need a mechanism where I can store a data in RAID, but also make sure that the data is even stolen by someone doesn't understand it.
Encryption.
Encryption is a way. But when you do encryption, the problem is people can decrypt it also. Right? The mechanism to decrypt it. But if I take our data and break it down in a way, first I will break the data, and then after breaking the data, elongate it and then replicate it. Again repeating, take a data, split the data, elongate the data, right? And then store it in RAID.
Actually, by locate.
I will explain you the example. Elongate the data means expand the data in terms of adding more unwanted things. Right? That thing is called as parity. Okay. So if I have a name like Harish, I will split HAR, ISH. I'll put HAR, I will put XYZ, ISH, I will put PQR. I take these two data and put it in two places. Right? Put it in two places. What will happen? Somebody gets a data from the first disk, will it be able to decode it? Because it has got only the fraction or the segment of the data. You can decrypt the data if you have full data, but you cannot generate a data if it is partial data. If I give you a half of the novel, can you predict what is happening in the next part of the novel? It's only the guess, right? Isn't it? That technique is called as erasure encoding. Clear? Better than the encryption. I would not say better, but it is one of the way to secure the data in the redundant disk. When you are replicating into a different disk, you basically are splitting the data, expanding the data, and then storing into multiple disks, so that only a section or a fraction of the data is there in particular disk, so that tomorrow if that particular data is down, again there is one more important aspect, if that particular data is lost, you can still generate the remaining part of the data using a formula. So if my name is HARISH, let's say if my name is Harish, right? If I split into two, HAR as this is ISH, right? I put X here, Y here, Z here. Okay? I store this into three places. Right? Tomorrow this data goes away. How should I recognize what is missing? I should be able to recognize, right? Right? I should be able to recognize. So what I will do, I will create a formula. I'll create a formula that can tie the missing piece. Okay? That encoding is called as erasure encoding. I'll explain it. It's a very simple example. Now you'll understand. So let's say you have a number 95 to be stored. Okay? So if I split the 95 into two parts, one will be 9 and other will be 5. If I specify X as 9, Y as 5. Okay? X as 9, Y as 5. And I don't store the number 95. I store X and Y every place. One formula is X plus Y is 14, X minus Y is 4, 2X plus Y is 23. I store the formulas. Am I storing the data? No. I have split the data and I have elongated. Basically, I have added a parity. I have basically made it dirty by putting some formula. Now X plus Y is 14, X minus Y is 4, 2X plus Y is 23. Let's say X plus Y is 14. What is X minus Y? 4 and 2X
Plus Y, 23.
Y is 23. If I take this information and I stored it into 5 disks. Okay, I stored it into 5 disks. Same data stored in 5 places as a RAID. If anyone gets this information, what will they do? What is X and Y? They don't know. Until this, or if I store this 3 into 3 disks, one has got this information, second has got this information, third has got this. Even a person has stolen this, what will he understand? In order to get the correct data, you have to solve this equation, right? So x plus y is 14, x minus y is 4. Subtract this, 2x is 16, 18. X is simultaneous equation, anyone knows? People studied simultaneous equation, right?
Yes.
So if I have to solve this equation, this x will go, this is what, 2x, this is what, 18, x is 9. I got the value of x, I can substitute it here, I will get the value of y. Right?
Yeah.
Am I storing the data? I'm not storing the data, I am splitting the data, adding a parity over it using a formula, and then I'm storing the parity in encrypted data inside the disk. This particular mechanism in Hadoop is called as error-sure encoding through a fault tolerant. There are many algorithms. This is the simplest one I thought of giving it to you. Okay.
How does, I'm still thinking about how the concept here, we want to save data on a lot of, like, replicate the data. Now, your concept is we are breaking the data rather, we are not saving those.
We are still saving. You will still save it in RAID. What is the problem which RAID was not able to handle?
Protect people from.
Only the problem, the biggest problem it solved was it is reliable, right? You can get the data from any node even if it is down. The only drawback which RAID had was if any of the disk is compromised, you're losing a data, right? That portion of the data. Let's say if a particular data set disk is hacked, you are losing everything, right? How to protect that?
Yes, this from my email.
You can either do encrypt and then store it. The problem with the encryption is also encryption has algorithm and encryption takes a lot of resources to do the encryption. So we will have a project in our organization every 3-4 years, we will have an encryption project where database is being encrypted when we do the migration. Encryption is a tedious process. You can have encryption software like Guardium and all those things, you can use it, but you have to go through entire process. And encryption needs to be periodically updated also, right? Because based on the new changes, right? Secondly, in this error-sure, it's a low cost effective measure. What I am doing, I am still storing the copy of the data, but I am not actually storing the data, I am storing something which is a coding format of data, coded form of data. I'm not actually storing 95 anywhere, right? Am I storing? I'm not. I'm storing some variables that are tied up with the data.
Okay. So it will be the same data on all the individual, just that each of them would have different coding that represents the same data.
Replicated across the different disks. That's it. Okay. Again, this is the simplest mechanism. This is the easiest one, right? It's not easy like that. Okay. It has got more complex programming behind it. Okay. Clear?
Yeah.
Highly available, you all know. If one data node is down, you can get the processing done from other data node through a node manager, right? Low network traffic because processing is happening on the data node through data locality. There is less of network traffic. Once the processing of mapper and reducer is being processed, only the final result is sent back to the name node to consolidate it. So there is a very less of network traffic back and forth of data movement. High throughput I have already explained, since it is a parallel processing, everything runs in parallel, so it is faster to get the processing and a high throughput of data processing happens. Open source, Hadoop is an open source technology, its source code is freely available, we can modify the source code to suit the specific requirement, okay. Scalable, we already know, it is highly scalable, you can spin up new data nodes as much as you want in terms of clusters. Ease of use, so you don't have to worry about the mapper and reducer processing, it's handled by the Hadoop ecosystem itself, you have to just manage the source file coming into picture. Compatibility, it is a backward compatible with many of the older version as well as Hadoop is compatible with many other ecosystem which we studied, right? Zookeeper, what was the Avro, all the diagram which was there, right? Hive, everything that is getting connected with Hadoop core system. It supports multiple language like C, C++, Python, Ruby, Java, and all those stuff. Okay, whichever language you would like to write a code, you can write it, and it has got a developer community for the same. What are the disadvantages of Hadoop? The first foremost disadvantage is issue with the small file. Hadoop works efficiently if you have a large file broken down into smaller file of 256 MB. It's good practice to have a huge file and then let's say I have 1 gigabit of file, I can break it down to 256, 256, 256, 256. Each 256 goes to each of the data node. Good processing you will see. But if I have a file of 20 KB, like you all did your assignment with 10 KB file, you will not get the benefit. That's why I told you when you do an assignment, take a 40-50 MB file. That will show how mapper took time and how reducer took time. If you take a smaller file, is like hitting a small nail with a big sledgehammer. No point, right? You take a big nail and you hit it, then it makes benefit, right? Otherwise, you will break your finger. Same thing happens here. If you have a small file, the processing or the management of the resources becomes difficult, right? Because you are spending most of the time in splitting the job, dividing it into smaller files, consolidating it. 40 KB file split into 10 KB, you are wasting your resources on all data node by acquiring 256 MB of resources. It's a waste, right? Plus the node manager has to work a lot. Your resource manager also have to work a lot to maintaining it. Name node should also work a lot because it has to maintain that big file list unnecessarily. It's vulnerable by nature. Hadoop is written by Java, so it is very much susceptible to hacking. Okay. But again, you have controls to stop that vulnerability. Processing overhead in Hadoop, the data is read from the disk and returned again. This is one of the biggest drawback why we will be studying Spark in our upcoming class. This point number 3. Why we are going to study Spark is of this reason.
Processing overhead.
Whatever processing that Hadoop does, right? It does on your disk. Right? If you put a file in HDFS file system in different location in the directory path structure, everything is stored in a disk, like your FAT system, NTFS system, right? Similar to that Hadoop file system. Every time your mapper and reducer is running on the disk, the problem is the performance deteriorates if the performance of a process is measured in the disk processing, because this takes time to process. What is the faster way to process this? Run it in the main memory or RAM. So right now, whatever processing we have done through Hadoop mapper and reducer, if that program is triggered in your machine, it goes in the data node folder and get executed in the disk location, right? The problem with that is when you are running through disk, everyone understand if I put 3 things, can you tell me which one is the fastest and which one is the slowest? Okay, then you will understand it. So which is the fastest?
Catch,
Why?
because is familiar with it already, so he kept it. It's not
I'm not talking about cache storage. I'm talking about what is cache memory.
yeah, I mean, okay, that's what I'm saying. Which is fastest is what you're asking.
Why?
And that's what I'm saying, that catch is usually kept from the
You are telling
previous.
me the cache functionality that it keeps the same type of transaction into a place
Yes.
which can be read faster because it is reusable
Yes,
and it gives you faster. But I'm saying I'm talking about cache memory.
the cache.
So the fastest is cache
Cache.
memory. You are right,
Yeah.
because the cache memory is a what do you call it, as a very high what do you call it as?
It's a volatile.
I'm missing the word, what it is called. It's not coming in my mouth. So it's like a memory which is spontaneous. I'm missing the actual word. It is not. So it's the memory that is designed to be faster than RAM. I'm not getting that word. There is a specific word that is told. When you instrument that hardware, right? So you allocate a specific type of material for cache memory.
Dedicated memory.
Okay, it becomes very fast. Okay, then you have RAM. RAM is nothing but main memory. What is hard disk? Your CD-F drive. And what is external drive? Something which you connect through USB-C port or whatever, right? The fastest is this, slowest is this. Because this one has to write the data through USB cable, C drive to your hard drive. Hard disk is something which is inside your machine, faster than external drive because it doesn't have to connect through USB. It will connect through the transport bus inside the PCB, your motherboard, right? You connect through that. So if you open a hard disk, anyone has seen opening a hard disk?
Yeah,
By screwing and opening up, what do you see?
there's something round.
Yeah, so you will see a lot of disks like this. Right?
Yeah.
It is one above the other, right? Piled up, and it is piled up so close that you cannot see with your eyes, right? So if the disk is like this, like a magnetic disk, right? Assembled, clumbled together in a cylinder, right? And then you pack it in the box. So if a data is written here on the top of the layer, and the other data is written on the fifth disk, third data is written on the, let's say, 30th disk, the bottom, right? That so there is a head, right, which will read the track, right? It's like a CD reader. So it reads it here. If it has to read another data, it has to spin up, go back, head has to move, go down, it has to go here, right? It has to read it. So every time the disk has to rotate, the speed of the disk has certain limitation. You cannot have a disk rotate at 50,000 RPM, right? It can rotate at certain speed. There is a delay in rotating the disk, so it takes time. In your MapReduce program, when you're storing your data in your data node, you are basically storing in the disk, right? Whenever a MapReduce program is running, it is actually doing mapper and reducer program in your disk. So it takes
Some
time.
of our computers, they are SSD.
Even SSD.
It also has that disk inside.
Yeah, it doesn't have a disk, but it has a concept of still reading from the track. And so when I say reading from the track, it has to go to the sector and move the head and read it from that location, right? That will take time, right? So the problem, the HSD and SSD can move at a certain speed. You cannot go at the speed of RAM. RAM is what? It's a main memory where your operating system is hosted, right? So your operating system is running and you have this much space, right?
Yeah.
If I take this space to store the data, my processing will be faster than this. Because I don't have to go to the disk and do an IO operation. When you go to the disk and read the data, this is called an input-output operation. I don't have to do this task. Operating system will not tell go to the disk, go to the track, read the data and come back. It will directly read it from the main memory, which will be the much, I would say 1,000 times faster than what is happening here. The problem with the Hadoop is everything is stored in the disk and the processing happens good. You are seeing very nice response time, but I'm not satisfied with the time. If you put this data in here, if this takes, let's say 10 seconds, this will take 20 milliseconds. 1,000 times faster. So that concept is Spark concept. When we go into the upcoming classes, when I will teach you Spark, the difference of moving from Hadoop to Spark is we will keep the data which are not frequently used in the disk. The data which we need it in frequent time, I will keep it in the main memory using Spark. I'll keep those stable data which is faster to be accessed. I will keep it here, and then I will use SQL Hive, right? Query language, right? I'll use SQL Hive and I'll pull the data from here rather than here. It will be faster, right? That concept is uses Spark, and that is the processing overhead what you have in Hadoop. Supports only batch processing. This is another disadvantage of Hadoop. Hadoop works fine in the batch processing type of thing, like loading of data. extracting the data. Loader and extractor process, very good, very bad in SQL query efficiency. That's the reason we use Spark. Iterative process, even though it runs a parallel processing, one of the biggest drawback, another drawback is it still works something sequential. What is the sequential phase here? Your reducer cannot run until unless what?
My what?
Even if it is a parallel processing of your files, I'm still saying there is an iterative process. Iterative means sequential process in this entire phase. Your reducer cannot run until
Until the mapper is
mapper is not completed. So it's a sequential, right? Can you start your reducer reducing it before mapper? No. Still, we have not fully put a parallel pipeline, right? So that is one other disadvantage which can be fulfilled by using Spark. Using RDD, directed acyclic graph, and I will teach you all. And last is security. Hadoop has a low security, but I will not go with the statement here. Hadoop can be implemented with a high security using Kerberos, which I will teach you. Again, it's not to that level which we need it, but yes, it does support security. Okay?
It's not a disadvantage then. The security is not a disadvantage.
It says that you can put Kerberos authentication and other mechanism, but it is hard to implement at the large organization. Okay? Okay, that's there for today's class. Any questions? No questions. Okay, people on the Zoom link, I am closing the WebEx. If you don't have questions, thank you, everyone. And I will send you the slide and record.
This sweater is so nice.